Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is three paths. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. For a given binary grid of A of size n cross n, we define function of A as the number of distinct write-down paths that can be taken from 1, 1 to n, such that all the cells that we visit are set to 1. A write-down path means that we can either go to the right or to the down. Now our task is to construct a grid A with exactly 3 paths, or claim that there exists no such path and give -1 as the answer. If there exist multiple such answers that have exactly 3 paths, we can print any one of them. So for the input format, we have t test cases. For each test case, we have a single line that contains a single integer, that is n. And for the output, if it is possible to construct a grid such that it has exactly 3 paths going from first the leftmost corner cell, that is 1, 1, to the rightmost cell, that is n, if there are exactly 3 paths, we print that matrix, otherwise we print -1. As for the constraints, number of test cases will go from 1 to 49 and value of n will go from 2 to 50. Let's see some sample inputs. So for the first sample input, we have n as 2. So we have a grid that is something like this. We have 2 by 2 cells. If I start from here, I have to end up here, and I can only go either right or down. First, if I choose to go right, then I can't take any more rights, so I go down. This is the first path. Then again, I have taken the right path. Let's go down. If I go down, I can't go down further, so I take a right. This is the second path. I do not have any other third path. Therefore, the answer is -1. Let's see how we can get the answer for the second sample input, where we have a grid of 3 cross 3. We have 3 rows and we have 3 columns. Again, we start from 1, 1 and we want to end at n, n. So first, let's say we take a right. We keep on taking rights. If it's not possible, we go down, right? This is a right down path. We can only take right or down. This is my first path. What else can I do? We can backtrack. We go here. I can't take any other path. Again, I can't take any more rights. I have already taken down. Then I come here. I have already taken a right. So this time, let's take a down. We take a down. We again take a right and we again take a down. This is my second path. So this is first path, right? Then this is the second path merging from here. Then again for the third path, we do the same thing. We trace back and we again come here. We again take a down, we take a right and we reach. These are exactly 3 paths in a 3 cross 3 grid. Let's see how we can approach the solution. As we have seen in the sample input, for any grid, the very first path that we can make is simply going all the way right and all the way down. Sorry, we go all the way right, then we have gone all the way right. This is my first path. Then what we can do is, then we can try to trace back from where we came. When we are to this corner, we were not able to go anywhere right. Therefore, there was no path and we went down. But what about here, the previous cell? We already went right. We can try to go down one cell. If you go down as one cell, now this brings us one more path. Again, we can come to the right till here. We go one down. We take a right and again go down. This is my second path. Now, if you want to make a third path, we can again do the same thing. We can trace back from where we came and check the other path. Now, since we come here, we have already taken a right, we have already taken it down. So we come here. Since we have again already taken right, we again take one more down and again follow the same. So to give you an example, for a cell, for a grid of 5 cross 5, it would look something like this. So let me make one first. Okay, here we have 5 cross 5. Right. We start from the leftmost corner, 1, 1. We need to reach n, n. First, we go all the way to the right, then we come all the way to the down. This is the very first path. Now, what about the second path? Again, we try to trace back and see if there is any other opportunity that we can take. I'll use some other color. let's use white. So since we have already gone all the way right, all the way down, let's see anything else that we can do. Since we are already here, we will check the option here. Here, we have already taken down and right is not possible. We do the same here again. No other option, no other option. Here also, no other option. But if we come to this cell, we have taken a right, but left it's still, sorry, down is still open for us. So if we take a down, again we try to go right. Again, if you go right, this opens a new path. This was the first path, and this is the second path. Again, we try to trace back for the third path, right? If you go back, we have taken all the other option, but if you come here, we have taken a right, but we can also take a down. So again take a down, we again go right, and this is the third path. So what our answer is very simple. We first fill the first row, then we fill the then we fill the last column. This gives us the first path. For any other path, in the second last column, we simply start filling until we reach 3. So in this case, we only need to fill these two. This is the first path, this will give us the second path, and finally this will give us the third path. In this manner, any n cross n matrix, we can make exactly 3 paths and get our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve and take the input of n. If value of n is less than or equal to 2, we print -1, as we have seen in our sample inputs. But after that, for any n cross n grid, what we do is we simply fill the first row, that is 0, I. Then we fill the last column, that is I and n minus 1, right? We fill it with 1. This will give us the first path. Then for anything else, in the second last column, we fill until we have 3 paths. That will be nothing but filling 2 additional cells. And with this, we have a grid that has exactly 3 paths going from 1, 1 to n, n. And as you can see, I have AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve, take the input of n. If it is less than or equal to 2, our answer is -1. Otherwise, we initialize the grid n cross n with 0 values. Then we fill the first row and the last column. This gives us the first path. For the rest of the 2 paths, in the second last column, we simply fill 2 additional cells. Once that is done, we have a n cross n grid that has exactly 3 paths going from 1 cross 1, 1, 1 to n, n. At the end, we print this grid, and as you can see, I have AC in my Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a great day, and I'll see you in the next video.